All right, let's dive right into this. Welcome to today's Explainer, where we are setting the stage for a truly mind-bending journey into the universe's absolute most extreme phenomena. We're going to completely unpack the limits of reality today. We'll break down exactly what these cosmic giants are, how they actually work, and why they hold the ultimate keys to understanding our entire universe. So buckle up. Now, you might be wondering what happens when gravity gets so unbelievably extreme that not even light can get away. It kind of sounds like pure science fiction, doesn't it? But actually, this is the very real, fundamental reality of a black hole. It's a region of space-time where the gravitational pull is just so absolute, so overwhelmingly powerful, that light itself, literally the fastest thing in the universe, is completely trapped. Keeping this big question in mind, we're going to see exactly how the cosmos achieves this terrifying, yet honestly beautiful extreme.
So let's get into Section 1, Birth of a Monster.
To really understand this monster, we have to understand how it's born. Step 1, a massive star simply collapses under its own gravity. I want you to imagine the sheer, unimaginable weight of a giant sun running out of the nuclear fuel that keeps it puffed up and then suddenly crashing inward on itself. Step 2, because all that material is rushing inward, it gets extremely dense. We are talking about an incomprehensible amount of matter packed into a space that is constantly shrinking down. And finally, Step 3, because of that crazy extreme density, an immense gravitational pull is created. The star's own immense weight basically becomes its ultimate undoing, forging a brand new black hole. The real kicker here is how the fabric of space-time itself actually bends and warps under the weight of that collapsed star. That intense, dramatic curvature is what truly creates that incredibly strong, inescapable gravity. You aren't just being pulled like a magnet. The very geometry of the space around you is literally funneling you inward. It's wild.
Moving right along to Section 2, Approaching the Extreme.
Okay, so getting closer to the abyss brings on some seriously bizarre effects. First off, as we established, light bends strongly. Space is so warped that light paths curve entirely around the black hole. Second, time dilation becomes extreme. Time itself actually starts to behave differently the closer you get. And third, and this is perhaps my absolute favorite scientific term ever coined, objects can get stretched out. The gravitational pull at your feet would be vastly stronger than the pull at your head. This leads to a very real, very lethal stretching process that physicists officially call spaghettification. It's exactly what it sounds like. And yeah, while it's slightly amusing to say, it is a truly terrifying physical reality. Let's just pause for a second and look closer at that second point about time. Time actually slows down near a black hole, but crucially, this is only to an outside observer. This extreme time dilation means that, well, if I were safely watching you approach a black hole from a distant spaceship, I would see your movements get slower and slower. Your watch would appear to take at just a fraction of the speed of mine. The immense gravity is literally stretching time itself from my vantage point. Mind-blowing, right? Which brings us right to the edge in Section 3, the point of no return. We are now looking at the very threshold, the event horizon. This is the ultimate boundary beyond which absolutely nothing can escape. Once you cross this invisible line in space, there is no return. It is the definitive cosmic one-way ticket. Any light, any matter, any unfortunate astronaut that slips past this boundary is just forever cut off from the rest of the observable universe. So, if you fall past the event horizon, where do you actually go? Well, you head directly toward the Singularity. This is the absolute dead center of a black hole. Here, the density doesn't just get really high, it becomes practically infinite. All of the mass from that massive star we talked about earlier is compressed down into an extremely tiny point. It's a concept that really pushes the very limits of human comprehension. I mean, infinite density packed into zero volume, it's incredible. Let's just consolidate everything we've covered so far. Basically, a black hole is an extreme region where gravity traps everything, with singularity right at its core. If you remember literally nothing else from this explainer today, lock in this one fact. It perfectly encapsulates the whole anatomy we just explored, the gripping, inescapable region of the event horizon, and that mind-boggling tiny point of the singularity just waiting in the center. Now let's zoom back out for Section 4, Unlocking the Universe. You know, it's absolutely vital to remember that we aren't just discussing abstract theoretical math equations here. This is grounded reality. The existence of these intense space-time curvatures was originally predicted by none other than Albert Einstein. But even more amazingly, we don't just have to rely on his predictions anymore. The very first image of a black hole was actually captured by the Event Horizon Telescope. We have actual photographic proof of the monster's shadow. We can point our telescopes at the sky and quite literally see the boundaries of the unseeable. And this all builds right into the absolute biggest challenge in modern science: relativity versus quantum physics. You see, relativity explains the big stuff like gravity, stars, and spacetime curvature. Quantum physics, on the other hand, explains the tiny stuff, atoms and subatomic particles. For decades, these two massive rulebooks have completely refused to work together. But inside a black hole, specifically at that singularity, you have immense gravity from relativity crushed down into a microscopic quantum point. So black holes are the physical arena where these two entirely different unsolved realms are forced to collide. Which brings us to why this all matters so deeply to us. Studying these phenomena isn't just about collecting cool space facts for a trivia night. It fundamentally helps us understand how extreme gravity works. It serves as the ultimate testing ground to connect relativity with quantum physics, and maybe, finally, solve those glaring mysteries in science. Ultimately, studying black holes is the absolute key to understanding the grand architecture and structure of the universe itself. By understanding the extremes, we figure out the rules that govern literally everything else around us. So, I want to leave you with one final provocative question to chew on. What will black holes ultimately reveal about the hidden structure of our universe? Every single time we look deeper into the dark, every time we capture a new image or solve a new piece of that quantum puzzle, we get just a little bit closer to the very blueprint of reality. Keep this question in the back of your mind as you continue to follow the incredible discoveries happening in astrophysics right now. Thank you so much for joining me on this cosmic journey today, and as always, keep exploring.